Alright, so we're looking at 8.3, graphing rational functions, moving on from simplifying yesterday. We're not going to spend any time talking about these, but make sure you print them and make sure you know what they are. There's a lot of new vocabulary in
or
this.
just pause it, write them down. So
Hit pause, write them down, sure. Okay, so this is the big ideas here for graphing. Just like yesterday, we need to make sure we factor everything, and then we'll look into determining these points of discontinuity.
And that was some of the stuff on the previous slide, the holes in your vertical asymptotes here.
Yep, the big words, big vocab words here. So looking at one example, we would go ahead with this one and say that there's a vertical asymptote when x equals 5. So right here, 5 would make the denominator 0. And
we can't divide by 0, so that's why it's a point of discontinuity. You have to lift up your pen or pencil when you're graphing this. That's why it's a point of discontinuity. You couldn't draw it in a smooth curve.
And we'll show you what it all looks like when we actually put some on paper. But that's what we need to know right there. Vertical asymptote at x equals 5.
Alright. Next one, we got to look to factor, just like the first one, but there was nothing to factor. Look at the top, nothing to factor. Bottom will factor. Factors to x minus 3 and x minus 1. And then we got to look at our points of discontinuity. 2 more vertical asymptotes. All right.
One here when x equals 1, and then one here when x equals 3. 2 vertical asymptotes. Last example that we'll look at on this slide, again, the denominator is already factored, but the numerator we can factor into x minus 4 and x plus 1. So far we've only had vertical asymptotes. Here's one example of when something actually does cross out, we're able to get a hole in the graph at x equals 4.
Yep, when you can divide those out and cancel them out, then you get a hole at that point when the denominator would give you a 0. So.
And vertical asymptotes when you cannot cancel anything out, holes when you can cancel out. A few examples to practice here. So think about it for a second. Will we get a hole or a vertical asymptote? If you said vertical asymptote, you are correct at -4.
First step, factor that top. We can cross out the x minus 2's, which gives us, instead of a vertical asymptote, a hole at 2.
Okay, so that's the big difference. Holes versus vertical asymptotes. And the last one, numerator's good. Denominator can be factored into 3x minus 2 and x minus 3, and you notice that you can cross these out, so we would have a hole at 3.
And the other one that doesn't cancel out gives you a VA, so you set that equal to 0, add 2, divide by 3, you get a VA, a vertical asymptote, when x equals 2/3.
Okay. Pretty straightforward here. Nothing can cancel out, so we'll have a vertical asymptote. 0 is what makes the denominator 0.
Can't we just cross out the x's?
No way, you crazy?
Oh man.
Hey, that's a common mistake, and that's why Mr. Winters brought it up, is because a lot of people want to cancel out these x's here, but that subtraction tells you that it's not just an x.
It's not a factor. It's not being multiplied by -5, so that's why we can't do that.
Exactly. Next one we're looking at here, again, numerator is good. Denominator, we factor it. Nothing can cancel out. No holes in this one, but it looks like we'll have 2 vertical asymptotes, one at 4 and one at -3. Again, last one here.
Nothing cancels, so we get some VAs. Set the bottom equal to 0, add 1, divide by 3, and you get a vertical asymptote at 1/3.
Okay, so that's the whole process here of finding vertical asymptotes and holes in the graph. Take a quick look at this here. We'll put this up on the next slide as well so you can look at it while we're doing it. But you want to make sure that you know and understand what all of this means. Refresh what the word degree stands for. And then here it is real quickly. Okay, so
just cancel and do another second half.
Okay, all right. Well, we'll go ahead and do a part 2 for this one, which focuses on horizontal asymptotes. And
Mr. McVeigh will be here, so
special guest here for the horizontal asymptotes, Mr. McVeigh.